Section 2.3, more on solving linear equations. There's not really anything new in this section. All we are doing is we are combining the algebraic property of equality with the multiplication property of equality and solving equations that require both. Our first step is to still simplify each side of the equation separately. So two separate problems, combine like terms, distribute, get them as nice and neat as possible. And then we're going to isolate the variable term on one side. This is, we're going to be using section 2.1 for this, moving things around. And the difference between what might happen here on 2.3 as opposed to what happened in 2.1 is every time in 2.1 we were able to get the variable term on one side, we got either x or negative x. And now we might be able to move things around, but we'll end up with 2x or 4x or something else like that. And then we want to get the variable completely by itself. This is section 2.2 material, where we might have to divide both sides by something. Basically, we simplify each side. We use the addition properties to move things around until we have our variable on one side and a number on the other, and then we divide both sides or multiply both sides if we need to. So let's look at our first example here. Both sides are already as simple as they get. We don't have like terms. There's nothing we can do. Now we want to get our variable on one side together, and I can choose either to move the 4r over to here or the 3r over to here. It does not make a big difference at all. It is workable no matter what. Now, just so that I can show you one particular thing, this is the only reason I'm making this particular choice, I am choosing to move the 4r over to here. And this is mainly so I can show you why a particular property we learned in 2.1 actually works. If I'm going to move this over to here, and this was a positive 4r, I'm going to subtract 4r from both sides. Okay, so that cancels out there. I have a 2 here. 3r minus 4r, that's going to be a negative 1r, or just negative r. And I still have the minus 6. Now to get my variable term alone, that meaning term, it means we're allowed to have a number in front that's not just a 1. It's implying that it's likely that we have something other than just a 1, although sometimes we won't. Now I want to move this over to here, get it away from that variable, isolate the variable term. So add 6 to both sides, plus 6 plus 6. And we have 8 equals negative 1r, which is the same as negative r. Now the property we had in section 2.1 said that if we ended up with this, all we had to do was to change the sign on both sides, and we had our answer. Negative 8 equals positive r. We're done. That's correct. What I mentioned in section 2.1, though, was that we wouldn't understand why that worked until we had 2.2. Now I can show you why that works. What we have here is 8 equals negative 1r. We have a multiplier in front. What we learned in section 2.2 is that you should divide by that same value to make a positive 1. If I divide both sides by a negative 1 here, I now have a positive 1, which is the positive r. 8 divided by negative 1 is negative 8. This is why that property works. Technically, you're dividing both sides by a negative 1. I could have avoided this altogether by choosing to move the 3r over to the left instead of the 4r over to the right. It's workable either way. You will end up with your own preferences. Let's check out this problem. 2x plus 1 is equal to negative times x plus 3. Now remember, that's a negative 1 right there. And that means I need to distribute. Okay, I can't simplify this side at all, so I'm going to recopy it. 2x plus 1 equal 2. Distribute a negative 1. That means it's multiplying all the way through. Negative 1 times x is negative x. You might want to put the negative 1x in there for right now. Negative 1 times 3 minus 3. Okay, so we've simplified each side. Now we need to get our variables on one side together. So I'm going to move this one over to here. Negative 1, so I'm going to add 1. We are moving across the equal sign. I'm not trying to get the number away from the x. I'm just trying to get the x's on the same side. So I'm adding 1x to both sides. Now this gives me 3x plus 1. That canceled out, equal to negative 3. So this is the first time we've moved our x's to the same side of the equation, and we ended up with a number still in front of our x. So this is just going to require us to use all of our properties. I'm still trying to get the variable term by itself, so I need to get this 1 away from the 3x. So I need to move this over to here. So I use the addition property again. This is plus 1, so I subtract 1, moving things across the equal sign. 3x equal to negative 3 minus 1, that is negative 4. Now, isolate the variable. This is section 2.2. I need to divide both sides by 3. Three divided by 3 is 1, so this is just x equal to negative 4/3. That is a fraction in lowest terms. It is a perfectly good answer. If you were asked to switch to a mixed number or a decimal approximation, then the directions in my math lab would tell you to do so in blue near the blank.